Long ISP, the Tiplady turntable, by Atticus Tiplady. The purpose of this ISP is to create a functioning record player that is able to take the vibrations of the vinyl discs spinning on a platter by a stepper motor and convert them into electrical signals that are amplified and outputted on a speaker. The Tiplady turntable is a custom-made record player that allows different vinyls to be played at either 33 1/3 RPM or 45. The key idea within this project that helps discuss how this project works is how a normal record player is able to convert the small grooves within a vinyl disc into sound. The stylus, needle found at the end of the tone arm, is able to retrieve music off of the 12-inch disc due to its magnetic field found within the needle's cartridge and the varying groove heights of the disc itself. As a diamond or sapphire needle is placed onto the vinyl, it physically touches the grooves within this disc, which contain tiny variations and ridges representing a specific sound wave and its information. As the needle moves across the disc, the small vibrations causes a magnet to move within the cartridge of the needle. As the magnet vibrates, a magnetic field is created that changes based on its position relative to the stylus, interacting with the coil and creating varying voltage signals which can be amplified into sound. Therefore, this means that the stylus is able to function as it converts the small vibrations into small electrical signals that phono amplifiers are able to pick up on and increase the magnitude. Now moving on to the motor. The turntable is able to function through the use of a stepper motor, specifically a 12-volt, 28 BYJ 48 motor tied to the platter in the center through the use of a rubber belt. Microstepping within the circuit is important as on its own the stepper would not be able to achieve the necessary torque in order to spin the platter. Stepper motors operate by turning a very specific degree, a fraction of the full revolution. For example, the stepper motor incorporated has a step angle of 11.25 degrees, and since the gear ratio within the motor is equivalent to 64:1, the steps per revolution is 2048. Microstepping control divides each full step into smaller steps to help smooth out the motor's rotation, meaning that since within this code there are 8 iterations of microstepping, in total the motor does more than 16,000 steps per rotation. A stepper motor, similar to the one found within this project, on average needs around 0.5 amps in order to function with a high degree. As a result, by using a 12-volt stepper motor while the rest of the circuit functions on 5 volts, a buck converter can be used to drop the voltage by more than half and double the available current, so the issue of a lack of current no longer becomes a problem. A Hall sensor is also incorporated to detect when the magnet that has been taped on the turntable spins past it. Upon spinning past it, the Arduino is able to take the time in between the two flashes and convert it to an RPM and display it on the side of the wood. The needle is placed on a 3D printed tone arm that was designed with 2 bearings in mind that allow a full range of motion in all directions. Moreover, the 3D designed tone arm sits on another 3D printed mount in which the cartridge rests. The Tiplady amplifier did not work as intended for the PCB as it acts as a solo amplifier, however fails to act as a phono amplifier. This was an oversight as online around half the needle cartridges have a built-in phono amp, however the one incorporated does not. My regular speakers, however, do have a phono input line and it alleviates this issue. A Phono Preamplifier, also known as a phono stage, is an audio component that amplifies the signal from the turntable to a degree that allows other useful components to further amplify. Furthermore, another important job of the Phono Preamp is to apply the RIAA equalization curve to the signal, reverting it back to the shape it was on the original recording. A Phono Preamplifier is then wired into a regular amplifier, which takes the now transformed sound waves and increases the intensity, causing the audio from the vinyl to be played out of the speakers. This is what my speaker does as the record spins. The elastic band spins another smaller disc that a vinyl is placed upon to remove some of the vibrations that are coming from the motor. However, some of them shine through when playing the audio, which sounds like this. If the phono amplifier were to be built within the circuit, this would be the diagram that would accompany it. And this is the diagram for the regular amplifier. The code is also quite simple for this project. The code begins by declaring everything within the circuit, and then follows that by creating 2 different arrays of both the 7-segment display controls and the microstepping features. The setup and loop functions are also quite simple, as the setup declares the outputs and sets up the external interrupts, while the loop cycles through the motor step process, a way to get around the stepper library. The 2 external interrupts are for A, the switch to switch between 33 and 45 RPM, and B, the code incorporated to take the reading from the Hall effect sensor and display it. Thank you for taking the time to listen to my project on the Tiplady turntable.